Hello students, welcome to our today lecture. In our today lecture, we are going to see that how to forecast values or how to forecast or how to predict anything by using VAR model. So basically in our previous lecture we have applied and we have seen that how to apply a simple VAR model, but in our today lecture we will see that how to predict or how to forecast in VAR model. So basically first of all we have to bring all of our data from Excel to STATA file. So for that I have to go to Excel file. I have to copy all my data from Excel to STATA file. Then after copying data from Excel file, go to data editor. Then paste all of your data here and go with this option that treat first row as variable name. Then click on OK. So as you can see that my all data is present here. I have 4 variables and my data set range is from 1996 to 2024. Then go back again to STATA, then go to statistics, go to time series, go to setup and utilities, then declare data set to be time series. Here in this option time variable, select year as your time variable, and from these options select yearly. As my data set is yearly, so I am going with this option of yearly. If you have data set weekly, then go with this option. If you have data set monthly, then go with this option. Then click on OK. So as you can see that now it has created my data set. Then go again to statistics, go to multivariate time series, then go with this option basic VAR. So here I select all of these variables one by one, and in this option it is asking about that how much lag you are willing to include in this forecasting. So basically let's say if I go with 4 lag option, so make sure that 4 lag option we are not taking it by our own choice. In our previous lecture we have already discussed that how to select what are the maximum lag length or what are the appropriate lag that we should include in our model. There are different lag selection criteria that tell us that how to or how much lag we should include in our model. So if I am going with this option of lag 4, we are technically saying that lag length selection criteria tells us that take 4 lags in your model. So I am going with this option that we are taking 4 lags in our model. So then click on OK. So now as you can see that it has given us the result for basic VAR model. So we are not interested in to explain these results as we want to forecast our analysis. So before moving forward, you have to check that either this VAR model fulfill the basic criteria for the applying of VAR model. So first of all you have to check that either residuals are normally correlated or not. Then you have to check the normality of the residuals as well. So we have to check all of these things one by one, and if they fulfill our condition, then we can make forecasting. So go to statistics, then go to multivariate time series, then go to VAR diagnostic and tests, then go to LM test for residuals auto correlation. Then click on OK. Here you can see that it has given us results for our desired test of autocorrelation, and the H0 is no autocorrelation at lag order. Basically when I was applying this test I have not selected how much lag should we include. So by default it has taken 2 lags and given us the result for 2 lags. So that's why here are the results for 2 lag. So H0 is no autocorrelation and H1 is, let me write here for you, H0 is there is no auto, and H1 is there is an issue of auto. Or you can say that residuals are not correlated, and in H1 you can say that residuals are correlated. What is the criteria for the acceptance and for the rejection of H0 and H1? If the probability value is less than 0.05, then we have to reject the null hypothesis. But in our case, as the probability of as the p value is greater than 0.05 or 5%, so we have to accept the null hypothesis or H naught, meaning that there is no issue of autocorrelation in our data set. Let me repeat it again. Here, for these results, our H naught is there is no auto or residuals are not correlated, and H1 is there is an issue of auto or residuals are correlated. If the probability value is less than 0.05, then we have to reject the null hypothesis and accept alternative. But in our case, as the probability value is greater than 0.05, so we have to accept the null hypothesis, which means that there is no issue of autocorrelation in this series. So now we are good in this option. Now we have to check either residuals are normally distributed or not. So go again to multivariate time series analysis, go to VAR diagnostics and test, go for test for normally distributed disturbances. Here you can see that there are different options: Jorka-Bera, skewness and kurtosis. You can select all of these, and if you are not willing to obtain these two test results, then you can uncheck them. At the moment we are interested only to obtain the Jorka-Bera test to see either our residuals are normally distributed or not. So I am going with this option only, Jorka-Bera test, then click on OK. So here you can see that it has given us the results for Jorka-Bera test. Now we have to make null and alternative hypothesis here. So the null hypothesis is that residuals are normally distributed, and H1 is residuals are not normally distributed. So if the probability value is less than 0.05, we have to reject the null hypothesis. But if the probability value is greater than 0.05, then we have to accept the null hypothesis. As you can see that all of these variables probability value is greater than 0.05. So we have to accept the null hypothesis, which means that residuals are normally distributed. So both of these tests guided us that we are good to go. At before this we have applied autocorrelation test, and we conclude that there is no issue of autocorrelation. And now we have checked the normal distribution of the residuals, and this test also tell us that residuals are normally distributed, so we can forecast now. For this forecasting we have to use the command for forecasting. And what is the command for forecasting? You have to type fcast, then type compute, then space m1, then comma, then write step. For example, I am interested to take, or I am interested to, or I want to forecast 12 years. So now we have to write here fcast compute m1, then step 12. After this, type again fcast graph m1 and type all of your variables m1 again, and your second variable, our second variable is POPD, then again m1, then next variable is GDPG, then again m1, and your next variable is FDI. So then press enter. So now here it has given us the forecasted result after 12 years. So now let's discuss about these results. So basically this result show the forecasted value for after 10 years from 2025 to 2035 or 36. So now let's discuss and interpret the results. As you can see from this this year to this year, there is a little bit increase in this variable, but after that next 10 years it will decline, and there is instability. But if you look at this variable is showing a declining trend over the time period. So we can forecast that after 2035, from 2025 to 2035, this variable is showing a declining trend, that this particular variable will go down and down over the time period. And if we talk about this variable, initially this is getting a upward trend, then there is a declining trend, and then it goes higher, and then it will be going down. Actually we should not word the use is. Basically we are making forecasting, so we have to use the word will. So because we are talking about the future values, as these results are for future, as we have make forecasting. So then from this time period to this time period there is stability, then again it will be declining. If we talk about this variable, from the beginning it will start from higher point, then it goes to it goes negative, then it will start increasing, then after reaching at a peak level it will decline again, and then at the end it will gain a stable point. So this is how you can forecast in VAR model, and this is how you can interpret results in VAR model.